Thanks, Anton. As we learned in the Kubernetes and cloud native infrastructure surveys, not everyone relies on Kubernetes for everything, but nearly everyone is using some sort of hybrid cloud environment, often including bare metal elements. Juju and the charmed operator framework can be a thread that ties together your multiple environments. Coming up next, watch as Thor Kristinsson walks us through high-performance computing environment on bare metal with Metal as a Service, MAAS, and Juju. Take it away, Thor.
Thank you, David. Hi, I'm Thor Kristinsson. I'm a product manager at Canonical, and I'm leading high-performance computing. Today, I'm presenting MAAS and Juju for cluster deployment. MAAS is Canonical solution for infrastructure management, vital for streamlining the delivery and deployment of servers in small to large environments. So why might someone need something like MAAS? It could be for various reasons, such as performance. But there is, for example, a need for certain kernel options or low latency. This often is the case in areas that depend on high-performance computing or telecommunication solutions. It could also be due to legacy reasons. For example, there might just be that database that just doesn't quite fit that well in the cloud. Or it could be due to security concerns or a need to keep resources locally, as is often the case in government, defense, and healthcare. But whatever it is, ultimately, MAAS is our solution for zero-touch provisioning of bare metal servers. How does on-premise without any tooling look like compared to the cloud? It is a pretty dire experience for most organizations, with a time to receive a VM from the cloud around 4 minutes, and for on-prem, it is around 4 months. If we look into the details, you can see how much work is needed in order to provision a bare metal server. In the cloud, this is all taken care of by the cloud provider. But for on-prem, the reality is that there are many tasks such as purchasing, delivery, installation, and validation. Many of these tasks can be handled or facilitated by building tools. Building homegrown tools has its own challenges, such as maintenance, bugs, and security. It's better for an organization to focus on their core business and competencies than to build their own metal management system. MAAS can significantly reduce the amount of steps needed for the successful deployment of bare metal servers, giving you a unified and a quick path into getting that server live. Not all workloads are going to public cloud, but the expectation of a cloud-like experience is here to stay. The abstraction of infrastructure is a powerful innovation and will be carried forward into any form of private cloud or edge computing solution. Not acceptable anymore to take months to get a machine. Programmatic interfaces, automation, and ease of use are paramount no matter where your cloud is. MAAS gives you the ability to provision many available operating systems onto many different server types. Abstracting away the operating system part, whether it be Kickstart or other OS-specific configurations, while also abstracting away the various bare metal controller implementations, giving you, the users, a cloud-like experience when deploying an operating system to a physical server. And as with many cloud solutions, that goes beyond just provisioning the operating system. MAAS can also be used through the various automation tooling available on the market, enabling the quick and easy deployment of full platforms. Anything from solutions such as OpenStack to Kubernetes. This has allowed organizations such as Roblox to migrate from Windows to Ubuntu in only 7 days, and others to deploy Windows on a large fleet of servers with ease. When we deploy OpenStack clouds for customers, our field organization uses MAAS for that deployment. The features of MAAS really go beyond simple server provisioning. I personally really like how MAAS can automatically discover networking devices, eliminating the need to map out every BMC IP address and credentials, and adding these servers manually. And I also really like how extendable MAAS is. Commissioning scripts are great for implementing common scenarios when it comes to adopting new servers. Think of common tasks like BIOS configuration, firmware updates, hardware testing. All could be implemented via commissioning scripts, depending on your organizational needs. So how does MAAS work? MAAS has a tiered architecture, and it is split into a region and rack controller. The region controller handles the logic and stores all machine and state information with a central Postgres database. It also provides a user interface and API for the operators, allowing them to manage machines as needed. The distributed rack controllers, or RACD, provide high bandwidth services to multiple racks. The controller itself is stateless and horizontally scalable, presenting only a REST API. The rack controller provides DHCP, IPMI, PXE, and TFTP, and other local services. They cache large items like operating system install images at the rack level for performance, but maintain no exclusive state other than credentials to talk to the controller. The rack controller handles the actual provisioning of servers, using power drivers to handle the power management of servers, telling them to boot and provisions the operating system. MAAS, as part of an overall canonical product portfolio, provides a seamless journey from day 0 to day 2 operations. We provide an integrated turnkey solution that works in even the most restrictive environments. MAAS effectively provides cluster management, the ultimate experience for bare metal resource discovery, management, delivery, and observability. Deploy anything from supercomputing clusters to enterprise infrastructures with ease test and validate clusters with commissioning scripts. And thanks to its ability to run in a highly available configuration and is split into regional rack controller, MAAS will stay up and scale well. Critical if you really depend on the environment. MAAS takes advantage of multiple other projects from Canonical, such as NetPlan, which provides a standardized way to define networking configuration. MAAS also uses CloudInit as a configuration mechanism for Ubuntu to provision networking, storage, SSH keys, packages, and various other system aspects. It is now the industry standard for all major Linux distributions in every major cloud. Juju can then be used against MAAS or other cloud substrates for setup and provides a declarative way to install, provision, maintain, update, upgrade, and connect applications across containers, virtual machines, and physical machines, anywhere by way of operators called charms. And of course, Ubuntu, the operating system for anything from supercomputing to enterprise workloads. Ubuntu is the ultimate distribution for high-performance computing. Recent kernel, extensive package repositories, 2-year fixed release cadence for LTS releases with 5-year support available, maintenance bug fixes by standard, extendable to 10 years with Ubuntu Pro, perfect for long-running environments. Ubuntu has an extensive list of packages available across its repositories, giving you a unified source for installation, which is critical for support commitments, available for local installation or public clouds. Our main and universe package repositories have some of the most extensive package selection out there, making them excellent for setting up environments. For example, we have schedulers such as Slurm and others available in our repositories, so no need for external repositories. The same goes for plenty of other HPC software and components required for packaging, such as SPAC. So you don't need to go looking for absolutely everywhere to find an installation method. It's very likely that we might just have the packages already available. So, simplify the delivery of HPC clusters with a canonical software stack. Charmed high-performance computing software could be just the solution you need to ease cluster operation and monitoring, all enabled with Juju and Charms. They help you simplify operations by assisting in the installation, maintenance, and integration of applications. So, to give a better overview, let me give you a quick view of HPC cluster architecture. So, what are HPC clusters? HPC clusters are a collection of resources used for the primary purpose of running computational workloads. HPC clusters consist of a cluster provisioner that ensures node homogeneity, servers, often referred to as nodes, a scheduler that queues up workloads against the cluster resources, a network for communication between nodes, a general-purpose storage solution used to store applications and user data, a high-speed, low-latency clustered file system, generally used for computational storage, and workstations that interact with the workload, either pre or post completion. And then auxiliary services like identity management to keep users' access consistent throughout the cluster. And observability and a monitoring stack that provides insight into workload resource utilization, and object storage in some cases. When it comes to the delivery, operation, and maintenance of clusters, it's good to look at the whole stack. MAAS gives the operator an extensive overview of effortless maintenance of cluster resources. It can be used for the provisioning of on-premise cluster resources, whether it is head nodes, compute nodes, or storage. Then charms provide package applications that ease operations and maintenance. Some interesting charms for high-performance computing clusters are charms such as charmed Slurm, which provides an HPC scheduler that's aware of the operational needs of HPC environments and their maintenance. Other schedulers are also available through charms, such as charmed Kubernetes. For an excellent experience in observability, of course, deployed through a charm, the canonical observability stack provides insight into cluster health and functioning, giving greater insight. Another interesting component is LXD, which could be used to provide pre-packaged environments that can serve the needs for workstation usage, head nodes, or pre-packaged computational environments for compute nodes, or just simple segmentation of auxiliary services. You can deploy LXD with MAAS for lightweight management of virtual resources. So effectively, with Juju and charms, you can easily deploy on-premise data center or edge bare metal environments for your computational cluster needs. If you want to learn more about MAAS and HPC, take a look at our blog series on HPC. It will give you a good induction. Feel free to scan the QR code to get more information. And when it comes to scheduling, let's not forget Kubernetes. Manage your cloud-native computational workloads with ease using charmed Kubernetes or microkits, our solution that offers container-based resource scheduling with a unified experience across substrates. At a very high level, Kubernetes clusters are made up of nodes, that is, servers intended for the sole purpose of executing workloads. They do that through an abstraction called pods. Pods are made up of a set of containers that run the workload. Containers maintain state and handle job execution on nodes. The operator interacts with a Kubernetes cluster through kubectl from his workstation, laptop, or any place of preference. A Kubernetes cluster might rely on multiple other components, such as identity management, observability, monitoring, and storage. So similar to the HPC cluster, Juju can be used against MAAS to deliver a charmed Kubernetes cluster for your cloud-native workload needs on bare metal servers, simplifying the delivery and operation aspects of standing up a Kubernetes cluster and overall maintenance. I urge those that have not already tried MAAS to give this tutorial a try. It's a quick way to deploy MAAS in a fully virtual environment, supplied with LXD, another great solution from Canonical, and allows you to get hands-on experience with MAAS, even if you don't have a physical lab of servers. Through the tutorial, you learn how to use Juju to deploy Kubernetes in this virtual environment. For information, scan the QR code to get a link to the tutorial. Thank you, and see you at booth P28. And I hope you all have a great operator day. Over to you, David.